Hey guys, welcome back. It's been a long time not recording, but yeah, let's just dive in. We're doing trigonometry today, and I'm gonna start with revision. So this is like grade 10 stuffs. So yeah, let's dive in. First thing first, we have our Cartesian plane with some points P and Q. So I'll just put for P the points, the coordinates that we do have. The x value, it's just gonna be a positive x value, so I'm gonna represent them in terms of x and y, and the y value is just gonna be just a positive y value. So we have that point P there. Let me just say this is K, and the angle it's theta, whatever theta might be, right? And yeah, cool, that's just P on the first quadrant. But if you go to the second quadrant, we have point Q. Right, and point Q, it represents this angle, so I'm going to use a red color. Point Q represents not that it represent, but yeah, that point Q, it forms the angle in red. I'll just call it beta, you know yeah. But in terms of coordinates of Q, we see that we have our x being a negative value of x, so we'll just put minus x. And then for the y value, of course, we see it's going to be a positive y. So that's there, we have it there. And with those points, maybe here, let me just say that is P, K, like V, I don't know, yeah, I'll go with V. So we're going to use Pythagoras theorem on both quadrants, just to see what Pythagoras says. And remember, just for a reminder, Pythagoras is like, say I have a right angled triangle over here, right? Say that's A, B, C, and of course the longest side is AC, the longest side of the our triangle, and we have a right angle there. Say this is A, this is B, and this is C. Pythagoras theorem says a squared plus b squared is equals to c squared. So that's what the theorem says. So we're gonna apply it using this Cartesian plane over here. So we will start with the first quadrant. Say, okay, I think also maybe I should just put that for the in a Cartesian plane under trigonometry, the longest side we just call it r. So let's go. It's gonna be the x value. Well, let me say we have OP squared is equals to PK squared plus OK squared. Right? So of course this is just R squared, OP squared, no, PK. So PK, like from here going on, I'll use this from here going straight up here, that's y values, so that's gonna be y squared. So yeah, so this length right here, it just represents the y values, because the x value on this line, PK, the x value is the same, the x value is just the value K, or just x, right? So that is cool. Okay, it's gonna be the value of x, from here all the way to the here, that's the value of x. So yeah, x squared. So that's just how it's gonna be. Something interesting on the second quadrant, we're gonna have OQ squared is equals to QV squared plus VO or OV squared. So as for QV is the y value. Remember, y is positive, so we have it like that. And VO is the x value, but the x value is negative, so we're gonna be like minus x and then squared, and yeah, just the young thing from grade 10. Also we dealt with Cartesian. We dealt with things called trig ratios. That's your sine, cosine, and the tangent. So we will just go again. For the first quadrant, so say we have sine theta. I'll just use sine theta. So we have cos theta, and we have tan theta, right? So now remember we had this thing called SOHCAHTOA. A1 so ka h 2 yeah, we learned this thing called SOHCAHTOA in grade 10, mainly to help us know what is a sine, what is a cos, and what is a tangent, right? So for sine, just starting with sine it says opposite over hypotenuse. So we're gonna go here and say we have theta right here, né? So this is angle theta right here. What is opposite sine theta? So we see that this is opposite sine theta. So pk is opposite sine theta, and pk is what? Pk is y. So we will have y, and our hypotenuse is what? Is r. Y over r. And then as for x, as for cos, we have cos. Cos is adjacent over hypotenuse. So adjacent, the side that is adjacent to angle theta in our case is going to be OK, which is x. So that is x all over r. And then as for tangent is opposite over adjacent. So opposite of theta, that's y. Adjacent, that's what? That's x. So that is y over x. That is just it. And then something interesting is gonna happen when we go to the second quadrant. So we can use point Q, right? We're gonna use point Q. And let us also say that we have r here as our hypotenuse. So we go again for sine. Didn't write. For sine beta is gonna be okay. So sine beta is gonna be, what is opposite beta? It's y. So it's gonna be y over r. And then as for cos beta, it's gonna be minus x over r. So then I can say, do you think you might have an idea why is it minus x instead of x? So you see that for cos is x over what? X over r. But then the x on the side, the x is what? Is negative, right? Sharp. And then for the tan, we have tan beta. That is gonna be y all over minus x, right? So the only interesting parts were, like, I'd say cos and tan, we are getting negative values just because we have a negative x value. So yeah, and then sine is positive. So this also says that, or it emphasizes that idea that sine is positive in the second quadrant. I can say, like, we had this thing. So in your Cartesian plane, we had this thing called cast. And cast, it helps you to know which trig ratio is positive where. So I will start with, let me start with C for, C. So C would represent cos. And then or A, it's just, I would say, all of them. S, that is for sine. T, that is for tan. Right, so basically second quadrant sine is positive, third quadrant tan is positive, fourth quadrant cos is positive, and on the first quadrant all of them happens to be positive, all of them. Right, so here we did second quadrant trig ratios, and for cos and tangent we get negative values. But when we go for sine, we get a positive value because only sine is positive on the second quadrant. So that is fine. Clear. Let's go and now cook something. So what we're gonna cook is special angles. And for special angles, there was a table I could have drawn here, but I was like, no. The thing is, so when I was still in high school, I never memorized, all those values, the special angles, to say, okay, so our special angles, let me write them down. We have 30 degrees, we have 45 degrees, we have 60. I could also include 90. I don't know, but I mean, Yeah, but nothing interesting about 90. So it's just this three. So the thing is, we um like for special angles, I'm not gonna say cram these values now, but I'll give you something that will always help you. So if you can understand and know this thing that I'm gonna show you, I'm telling you the truth. Any question you get on trigonometry about special angles, you're going to ace that question. You're going to ace that question, and you're not gonna have issues of you having forgotten what your values were. So let's cook. I'll start with the first one. The first one is my favorite, né? Because here what I actually did is so you have your right angle right here, then I would put 30 degrees, né? I would put 30 degrees. So one thing that I know for sure, like this one, I know it, né? I could say maybe this is what I memorized, or this is, I don't know, but this is one thing I never forgotten. It's that sine 30, right? Sine 30 is equals to what? Half, right? And then I know sine is what? Sine is opposite over hypotenuse. That means that if I go back to my triangle, whatever is opposite 30 degrees is what? It's gonna be 1, ne? And then the hypotenuse is gonna be what? It's gonna be 2, right? And if I have 90 degrees here and I have 30 degrees here, how much is that? It's 120. So to get to 180 degrees, which is the total sum of it's the total sum of all angles in a triangle. So the only angle that I'm missing is a 60 degrees. That will mean here we have what? We have 60 degrees. I'll just do this. We have 60 degrees. So, and now I just have this length to determine. Since I have this one and I have this two, I could just use Pythagoras to determine it. So Pythagoras will say, let me just say this is x. Pythagoras will say 1 squared plus x squared is equals to 2 squared. So then I have x squared is equals to 4 minus 1. That is 3. X squared is 3. So I then put square root both sides. Since it's distance, I won't put plus or minus. X is equals to square root of 3. Right. So that means here x is equals to square root of 3. So you see, what I will tell you is the square root of 3, I always forget it. Ne? So what I know is I just know that sine 30 degrees is half, which is 1 over 2. 1 over 2 hypotenuse, opposite over hypotenuse. So I just go to my triangle, then I use Pythagoras to find the other one. So this is basically our special angles using 60 and 30 degrees. So with this, like, you would get questions that would say, without the use of a calculator, simplify this. Ne? And the thing is, it's very important that you know how to get these values like this, because you can just try to rob them and use a calculator, but we're gonna see that you used a calculator. So it's best that you know how to get these values or this triangle. So it's like you would get something like sine 30 times cos 30, I don't know, minus sine 60 minus, oh no, times cos 60. This is just me making example. Né? Probably answer is gonna be 0, but let's see. So sine 30 is opposite over hypotenuse, that is 1 over 2. Multiply cos 30, it's gonna be what? It's gonna be adjacent, which is square root of 3, over hypotenuse, which is 2. And then we go here, sine 30, it's whatever is opposite 60, which is what? Which is square root of 3 all over 2. And then cos 30, whatever is adjacent 60, which is 1 all over 2, right? So you just realize, of course, Yeah, answer is gonna be 0 here. These things are gonna cancel out each other. But yeah, you need to know these angles. You need to know how to find your distances and values, because it becomes very easy. We'll do just a few examples. Another one, it's in this isosceles triangle. I think it's isosceles, because isosceles triangle, you find out it has two equal sides, two equal sides, two equal angles. Ne? So you have your 90 degrees here, you have your 45 degrees, you have your 45 degrees, right? Those are what? Those are what two equal angles. And then this side is equals to this side, right? And then one thing that I know that you guys should know is that this side is 1 and this side is 1, right? I mean, the other side, it becomes easier for you to find with theorem of Pythagoras. I'll just call it maybe y, and then we say y squared is equals to 1 squared plus 1 squared. That is 2. I almost said 2 squared, but that is 2. Yeah, then you put this both sides, y is equals to square root of 2. So this side becomes square root of 2. I would just say y equals to square root of 2, right? So you have your sides, you have your angles, you are sorted, né? And from there on, you can just use when the question comes and it says simplify this, it becomes really easy for you to I don't know, sine 45 multiply by tan 60, plus tan 45, right, divided by, I don't know, cos 60, cos multiply by cos 60, cos say 45. Let's just do it like this. And so sine 45, you go to the 45 degrees triangle. You can literally use any angle. I'll use this one. So sine is opposite, that is 1. So that is 1 all over square root of 2, right? Multiply by what? Tan 60. So I go back to my triangle. Tan 60, 60. Tangent, remember, it's what? Soka to a. Opposite over adjacent. So 60, opposite 60 is square root of 3. So it's square root of 3 all over adjacent. I think that is 1. Yeah, adjacent is 1. So then I have plus tan 45. I could use this one. Tan 45 is 1 because we have opposite over adjacent, so it's 1 over 1. So I'll just write 1 here. And then cos 60, let's go back. Cos 60, 60, cos it's adjacent over what? Adjacent over hypotenuse. So that is 1 over 2. 1 over 2 multiplied by cos 45, which is adjacent over hypotenuse, 1 over square root of 2. So the thing is, if you use a calculator, you can just check it yourself. If you use a calculator and you put sine 45 on your calculator, you put cos 45 on your calculator, it shows the way in which it simplifies it. I think it gives you square root of 2 all over 2, right? Yeah, because they basically, like the calculator, it uses this thing called rationalizing, where you'll multiply by square root of 2 over square root of 2, and then the square root thing just cancel off. So then you have 2 over square root of 2. Yeah, so this is the value you're gonna get when you're using a calculator, and you could be penalized for that. Even if your final answer is fine, it's correct, but you could be penalized. You want to get 100%. So yeah, make sure that you're using you know how to use just make sure you know how to get those angles and those sides. because from here it's just gonna be pure simplifications. I'm not gonna do it, but it's just gonna be pure simplification. Yeah, well, actually, let me do it. So you have square root of 3, square root of 2 plus 1. I could just say square root of 2 over square root of 2, which is still 1. And then we will have 1 over 2 square root of 2, right? Yeah, so our denominators are the same here in the numerators. Our denominators are the same, so we could have square root of 3. I understand. Square root of 3 plus square root of 2 divided by square root of 2, which is divided by 1 over square root of 2 square root of 2, right? So this whole thing, it's square root of 3 plus square root of 2 all over square root of 2 multiplied by 2 square root of 2 over 1. And then this square root of 2's, they cancel each other. So this, they cancel out. And then we're just gonna have the final answer of 2 square root of 3 plus 2 square root of 2, and that's it. You're done. But yeah, this is just, special angles. Let's see what we have next. I think it's just examples now. Cool. So we're gonna solve some examples. We're done with the revision. We're gonna solve some examples, and then we call it, I almost say we call it a day. But yeah, for this one we have to find A and B, right? We have angle 47 degrees. We have 30 units. I didn't mention what I centimeter. It doesn't really matter. So yeah, you can literally choose here. Now you can choose which side do you want to start with. If we start with A, you realize that, okay, A is what? A is a hypotenuse. So for cos and tan and sine, only cos and sine have hypotenuse. So cos theta, remember it's what? Adjacent over hypotenuse. And then sine theta is opposite over hypotenuse. So if we're starting with A, now you understand that they both have hypotenuses. So you're gonna either use sine or sine or cos. Tangent is TOA, so opposite over adjacent. So we could use one of these, but we check. So we have this angle 47 degrees, and then we have something opposite that angle. We don't know the side that is adjacent 47 degrees, so we don't know adjacent side, which is B. We know the opposite side, which is 30. So that means we have opposite side and we have the angle, and we need the hypotenuse. That means we're going to use what? We're going to use sine, because we have what? We have the opposite side, we have the angle, and we're looking for the what? For the hypotenuse, right? Cool. But then if you start with B, you realize you still don't have your hypotenuse. You still don't have your hypotenuse. So by you not having your hypotenuse, you can't use cos, you can't use sine. So you're gonna use what? You're gonna use tangent. And if you use tangent, let's go. You have the opposite side, which is 30 degrees. You have your angle, and you're looking for your adjacent side. So everything is fine. So do you see, guys, like how? Yeah. So I will use one method here, and I would say I would start with A, and I would say you guys start with B, right? Yeah, you guys start with B, and just let's compare the answers. So if I start with A, A, it's hypotenuse. We're gonna use a sine. We did talk about that. So sine 47 degrees is equals to sine is opposite over, so opposite over hypotenuse, right? Let me just say A. All right. So basically, just using simple math, gonna end up with something like this. Right, so then I put this in a calculator. Let me quickly get the calculator. So I have my calculator with me. That over sine 47 degrees. So what am I getting? I'm getting 41 point 02 02 ne 02. Man, I just want to say it's 41. So yeah, so we have the side there, it's 41. Then for the rest, remember, now you have this side, you have this side. You can just basically use Pythagoras to find b, ne? You can just use Pythagoras would say that a squared minus 30 squared is equals to b squared. So a squared is 41. Man, let me just say it's 41, ne? But when you're writing in your exams, like, just because in your exams they will say round your answers to do 2 decimal places. So now maybe let me just go on with 2 decimal places. So it's 0.2 squared minus 30 squared is equals to b squared. Go to my calculator. 4102 squared minus 30 squared. I am getting 782.64 b squared. So now I just put square root both sides. So go here, square root of 78264. The answer we get is what? 27.98, right? So therefore b is what? 27.98, right? Say for example, maybe I started with what? Say I started with b. If I started with b, I would have something like, I was gonna use the tongue. So tongue. Damn, there's a there's a lorry there making some noise. Hopefully, yeah, I'm sorry if it's really disturbing the video. They'll be gone in a minute. So term 47 is equals to opposite, which is 30, over adjacent, which is b. And then I do basically that 30 term 47. Wait, soccer are opposite over adjacent. Yeah. So I have 30 degrees divided by term 47. Woo! Damn, guys, we have b equals to 27.2. No, 0.98. So yeah, guys, so the answers matches, so everything is fine. So it doesn't really matter where you start, just know you get the same answer. For this example, I just put x in red, because I was like, man, this is just a simple Pythagoras. So it'll be something like square root of what? Square root of 24 squared. If I just use a calculator, plus 41 squared. So this will basically be the answer for x, right? So I'm not gonna do it. I'm not gonna do it. Let's just try to find theta, ne? Now you have opposite, a side that is opposite theta. You have a side that is adjacent theta. So that means what? That means you have, I'll just say tan theta equals opposite over adjacent, so opposite over adjacent, and that is b. That is gonna be 41 over 24. Let me see if it's not a long number. 21 over 24. It's really a long number, so I'll just leave it like that. And then I will say, so this is a trick that we do, like if we are solving, they are like some solve for x trigonometry problem. So we will do one of them. So 41 over 24. So that is shift, you go tangent. 41 over 24. Right? That is what? 59.66 degrees. Ne? And there we go, you are done with your angles. You have your angle, blah blah blah. Very simple, very simple. Okay, for this ones, remember special angles, né? They will say for these questions of special angles, they will say without the use of a calculator, try to do this, né? So I still have the triangles at the back of my head, so I'll just put them here. Like, hey man, you see, like, hey, during my high school time, I would literally like draw these triangles at the top of the question paper so that I don't get confused. Oh my god. Yeah, so we have 30, we have 60, 90 degrees, sine theta, sine 30, 1 over 2, and this is just square root of 3. Then we have another one. This one is 45, and this is 1, yes, and this is square root of 2. Yeah, well, and then you have your special angles, and you can just go on with it. They say 2, so you have, I'll use a red. You have 2 into sine 45. It's 1 opposite over hypotenuse. So 1 over square root of 2. Then we have multiply by 2. Cos 45 is just the same. It's 1 over square root of 2, right? And the answer is going to be what? The answer is going to be, you have 2 square root of 2 multiplied by 2 square root of 2. The answer is going to be 4 over 2, which is 2. Yeah. Let's do the next one. The next one there, it's sine 60. So sine 60 opposite over hypotenuse, that's square root of 3 over 2. Cos 30, that is cos 30 adjacent over hypotenuse is square root of 3 over 2. Then a minus 60 cos 60. Cos 60 is 1 over 2. Sine 30 also 1 over 2. Tan 45, that's just 1. Okay, and then we're gonna have that's gonna be 3 over 4 minus 1 over 4 minus, let me just say 4 over 4, right? Yeah, so man, that's gonna be what? On the first two we have minus, it's gonna be 2 over 4. So that means the answer is minus 2 over 4. Alright, so we're cool. And then the last one, this is where like we are solving, solving for theta. And for example, this one's the first and first, you just need to get rid of this, number. So you will have cos 2, right? And also you want to treat this thing as, perhaps let's do this now. Let's say let 2 beta be theta, and then you say you're gonna have what? You're gonna have cos theta is equals to 0.3 divided by 1 over 2, which is basically multiplied by 2. So I could say multiply by 2. And then we are solving for theta here. So you will have theta is equals to cos, right? So here quickly 0.6 so shift cos 0.6, we have 53.13. now, but now we go back, we have found theta, we go back, we like 2b equals to theta 53.13 to beta, therefore beta is gonna be half of this, so 53.13 divided by 2, that means 26.57 degrees. So then you're done. Yeah. Yeah, and this is just the end of our revision for grade 10. Right. So yeah, in the next couple of videos we'll be doing grade 11 materials. See you there.